Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of definitions and terminology on transaction and its properties. Transaction and its properties. So what is meant by transaction? How the transaction management will plays a major role in the real-time banking system. So transactions are nothing but what? A set of operations. Transactions are nothing but what? Set of operations that are used to perform a logical set of work. So a transaction usually means that the data in the database has been changed. So whenever you perform some transaction operations, that automatically the data gets changed. The data gets changed in database. So logical set of work, a transaction is nothing but logical set of works. So set of activities, set of operations that are used to complete the work, that are used to complete the task also. So one of the major uses of DBMS is to protect the user data from system failures. So executing the same programs multiple times will generate multiple transactions. So executing the same program multiple times will generate multiple transactions. So example, we can have withdraw cash from ATM. So withdraw cash is a transaction. Withdraw cash is nothing but what? One transaction. But to complete the transaction, what are the operations that you are going to perform? What are the activities that you are going to perform? So that's why we can mainly use it for the rollbacking of your data, mainly use it for the user's data you need to protect from system failures also. So here withdrawing cash is one transaction. To do that, we can have a separate types of operations. We can have different types of operations. So what are those operations? We can have different types of operations such as inserting card. Inserting card is one operation. The next is selecting language is one operation. The next is select account type. Select account type is one operation. Select money. So select money, enter the money is one operation. After that, wait for the cash and take the card is one. So to withdraw money, to withdraw amount from ATM, we can use this certain operation. So the steps are you need to follow like this. So inserting card, the next is selecting language. The next is select the account type. Select the option withdraw or deposit. The next enter the amount. The next wait for cash and card withdrawal. So like the way different types of operations, these are all nothing but what? Sequence of operations. That means if you want to withdraw cash from ATM machine, you need to complete this all the operations. That's why the transactions are a set of operations that are used to perform our logical set of work. So to complete that withdrawal task, we need to complete these all operations. So to performing these all operations, the transaction has to follow in different states and different properties. So what are the states? So here the states goes through which a transaction goes during its lifetime. So generally the transaction performs with the read or access data. The next write or update data. Or else commit the data. So read or write operations we need to perform on the transactions. But to read the data, to write the data, we need to have the transactions are which state they are having in which state. So here the states through which a transaction goes during its lifetime. So the following states which tells about the current state of the transaction and also tells how we will further do for the processing the transaction. So what is the current status of the transaction and what is the next status of the transaction, that is all about to know by using these transaction states. So these states governs the rules which decide the fate of the transaction, whether it will commit or abort. So here the transaction states are executed in two ways. The transaction states are executed in two ways. One is in success way, one is in successful transaction. And the second one is what? A failure transaction. So here the successful transaction, how it performs with a read or write operation. So present the transaction is in active state. Present the transaction T1 is in active state. Now if I perform a read or write operation, it will become in the next partially committed state. Again we perform some operation, it will move to committed state. After that it will committed to terminate state. So that is for all successful transaction. But for in the failure state, so suppose if I perform read or write operation on the data, then it becomes into partially committed state. So from that it becomes into failure state, or else it directly comes from the failure state. So after that the failure state will be rolled back because of it will be moves on aborted state. So if the transaction is in aborted state, you can roll back it again. You can roll back that data. But if it is in terminated state, you cannot roll back the data. So if it is in failed state, then roll back the data from aborted state, but it is not in terminated state. So active state to failed state to aborted state to terminated state. These are all the transactions to be failure states. So here each and every state is represented like what? So active state is the first state of every transaction. So it is the first state of every transaction. In this state, the transaction is being executed. So here, for example, insertion or deletion or updating a record is done here. But all the records are still not saved to the database because it is not entered into the partially committed state. So before entering it, it is in still not saved state. So that's why you can say that active state is the first state of every transaction. In this state, the transaction is being executed. So insertion or deletion or updating a record is done here. But all the records are still not saved to the database. Second one, partially committed. So in the partially committed, a transaction executes its final operation. But the data is still not saved to the database. So the final operation is executed, but the data is not saved in the database permanently. So example, total mark calculation. The final display of the total marks step is executed in the state. So if any student wants to update that marks, then it is in partially committed state. So next, committed state. So a transaction is said to be in committed state if it executes all its operations successfully. In this state, all the effects are now permanently saved on the database. So after execution of this committed state, now the data saved in the database permanently. Next, failed state. If any of the checks made by the database recovery system fails, then the transaction is said to be in the failed state. So if any database recovery system fails, then the transaction is said to be failed state. So in the example of total mark calculation, if the database is not able to fire a query to fetch the marks, then the transaction will fail to execute. execute. So that is the way of executing the transaction states from one state to another state. So aborted state. If any of the checks fail and the transaction has reached a failed state, then the database recovery system will make sure that the database is in its previous consistent state. Its previous consistent state. That is in rollback state. If not, then it will abort or roll back the transaction to bring the database into consistent state. Database into consistent state. If the transaction fails in the middle of the transaction, then before executing the transaction, all the executed transactions are rolled back to its consistent state. Rolled back to its consistent state. So after aborting the transaction, the database recovery module will select one of two operations, either restart the transaction or else it kills the transaction. Either it has to be restart the transaction or else it kills the transaction. So to do this, all transaction properties are used. Transactional properties are used. So there are four main properties of transaction represented in the acronym of ACID. So this refer to atomicity. So ACID is nothing but what? Atomicity property, consistency property, isolation property, and durability property. So what is meant by atomicity property? A transaction cannot subdivided and can only be executed as a whole and is treated as an atomic unit. So it is either all the operations are carried out or none are performed. So if the transaction cannot be subdivided and can only be executed as a whole and is treated as an atomic unit. So it does not contain it does contain single values. It does contain single values, not having more than values. And consistency. After any transaction is carried out in the database, it should remain consistent. It should remain consistent. And no transaction should affect the data residing in the database adversely. So after any transaction is carried out in the database, it should remain consistent. No transaction should affect the data residing in the database adversely. And isolation. When several transactions need to be conducted in a database at the same time, each transaction is treated as if it were a single transaction. As a result, the completion of single transaction should have no bearing on the completion of additional transaction. Completion of additional transactions. So that is the isolation property. So concurrent execution. So what is meant by concurrence is the transactions are executed simultaneously at one time in different places by the different users. So here in multi-user system, multiple users can access and use the same database at one time, which is known as the what? Concurrent execution of the database. It means that the same database is executed simultaneously on a multi-user system by different users. While working on the database transactions, there occurs the requirement of using the database by multiple users for performing different options like insertion operation, deletion operation, update operation, or modify operation. And in that case, concurrent execution of the database is performed. So multiple users can able to deposit money at the same time. Multiple users can able to withdraw money at the same time. So for this, concurrent execution is processed, and it should be done in an interleaved manner, and no operation should affect the other executing operations, thus maintaining the consistency of the database. So if at all not having any concurrent manner, then the execution of the operations is to be done in consistent way. Thus on concurrent execution of the transaction operations, there occur several challenging problems that need to be solved. So we need to face the different types of problems when we are performing concurrent execution. So what are the type of problems we are going to face in the concurrent execution? So in a database transaction, the two main operations called what? Read and write operations. The main two operations called as what? Read and write operations. So there is a need to manage these two operations in the concurrent execution of the transactions as if these operations are not performed in an interleaved manner. And also the data may become inconsistent. So if at all not performing interleaved manner, the read and write operations, they may having the data inconsistency. So the problems occurs with the concurrent execution of the operations. So like data inconsistency problems occurs, data integrity problems occur, data redundancy problems occurs. These are all some certain type of problems that are occurred in the concurrent execution, that are occurred in the concurrent execution. So multiple granularity. So what is meant by multiple granularity? It is defining that what it is a hierarchically breaking up database into the blocks which can be locked. So what type of database is there and what type of locks that are applied to the database fields. So it is a protocol. It enhances concurrency and reduces lock overhead. So it enhances concurrency and reduces locks overhead. So it maintains the track of what to lock and how to lock. So it maintains all the locks and what to lock and how to lock. So it is make easy to decide either to lock a data item or to unlock a data item. So if I want to lock a data item and unlock a data item, it is easier to decide. This type of hierarchy can be graphically represented as a tree. So it is represented as a tree. For example, consider a tree which has 4 levels of nodes. 4 levels of nodes. That is in this form, 4 levels of nodes. The first level or higher level shows that entire database. First level or higher level shows that what? Entire database. The second level represents what? A node of type area. A node of type area. The higher level database consists of exactly these areas. Exactly this area. So that means database is the higher level and it contain what? Areas. It contain what? Areas, and which contain what? Areas to files, and which contains what? Records. Which contains what? So here the area consists of children nodes which are known as files. The area consists of children nodes and which are known as files. No files can be presented in more than one area. No files can be presented in more than one area. Finally, each file contains child nodes known as records. So finally, each node contains what? Child nodes known as records. The file exactly those records that are its child nodes. Child nodes. And no records present in more than one file. No records are presented in more than one file. So here we can see the diagram. The levels of the tree starting from the top level are as follows. So we can apply the locks in the database level, areas level, files level, records level. So here database, this is the main root node, then next parent nodes, then next child nodes, and then next last leaf nodes. So this is the logs applied. You can database level. This is the area level. You can apply the logs, and this is the file level. You can apply the logs, and last the record levels also. You can apply the logs. Record levels also you can apply the logs. So to avoid that concurrent execution, what we can do, how we can do. So to control that concurrent execution, the concurrency control is the working concept. Concurrency control is the working concept that is required for controlling and managing the concurrent execution of the database operations. So here database operations are nothing but what? Read or write operations that leads to select, insert, update, delete operations. Select operation, insert operation, update operation, delete operation. So these avoiding the inconsistencies in the database. Avoiding for what? Inconsistencies in the database. So to do this, concurrency control protocols are used. Concurrency control protocols are used. So concurrency control protocols ensures what? Atomicity, consistency, isolation and durability, and also along with that serializability also executed. Serializability of the concurrent execution of the database transactions. So these are all some methods that are executed to control the concurrent execution. To control the concurrent execution. Therefore, these protocols are categorized as what? Lock-based control concurrency control protocol. Second one, timestamp concurrency control protocol. And third one, validation-based concurrency control protocol. So, log-based concurrency protocol, we can control, we can manage the concurrent execution by providing the locking mechanism. So, with the help of locking mechanism, we can control the concurrency execution process. And the timestamp, we can use the timestamps for each and every transaction, timestamps for transaction, to manage the concurrent execution process. And validation also, it validates the transaction based on the transaction type and the timing and all these validation criteria. Based on that, it controls the concurrent execution. So these are some methods to control the concurrent execution process. And concept of serializability and recoverability. So here a collection of transactions become a schedule. So we need to maintain a transaction 1, transaction 2, transaction 3 or become schedule. We need to schedule them. So scheduling multiple transactions is necessary to maintain the execution order and to avoid the overlap of data operations is called as what? Serializability. So we need to serialize the transactions. So withdrawal transaction is at what time, deposit is what time, checking balance is what time. So like the way we need to schedule the transactions is necessary to maintain the execution order and to avoid overlap of data operations is called as what? Serializability. So serial schedule. So there are two types of serial schedules. One is what? Serial schedule and the second one is what? Non-serial schedule. So serial schedule, both by definition and execution, means that the transaction processed upon it will take place serially. So the transactions are executed serially. So T1, T2, T3, like the way the transactions are executed serially. That is one after another. And this leaves no place for inconsistency within the database. So this leaves no place for inconsistency within the database. But when a set of transactions are scheduled non-serially, they are interleaved, leading to the problem of concurrency within the database. So non-serial schedules do not wait for one transaction to complete for the other one to begin. So there is no need to wait for one transaction to complete for the other one to begin. So serializability in DBMS decides if an interleaved non-serial schedule is serializable or not. So it decides whether the interleaved non-serial schedule is serializable or not. So that is nothing but interleaved manner of non-serial schedule will become serializable or not. So this is about concept of serializability and recoverability. So in this, the transaction becomes in the deadlock situation also. So what is meant by deadlock? So a deadlock is a condition where two or more transactions are waiting indefinitely for one another to give up locks. and it is said to be one of the most featured complications in DBMS, as no task ever gets finished and is in waiting state forever. So deadlock is a condition where two or more transactions are waiting indefinitely for one another. So that is nothing but the transactions which are executed for the next transactions which are executed for the next will be held by another transaction. That is nothing but the situation collision occurs. So collision occurs, then the deadlock situation automatically occurs. So here from this example we are going to see that the student transaction and the grading transaction, those two are held for the transaction executed, but one cannot execute it before another releasing the transaction. So the transactions are waiting for the resources that are utilized by the another transactions. So that is the way we can understand the deadlock situation occurs. So once again we revise the topics which we discussed in this session. So here the first one is what is meant by transaction, and what are the different operations that are used to perform the transaction. So here the transaction is nothing but what? A set of operations to complete the task, to complete the work. So here read or access the data, so read operation, and write or update the data, and commit operation. So these three operations are used in the transaction operations, and these transactions operations are used in the step by step to complete that work. So to do that completion of the work, the transaction is being forwarded in the different states. So from active state to ending terminate state, it forwarded into different state. So there are two types of states actually. One is for the successful transaction and one is for the failure transaction. For the successful transaction, the states are being forwarded as a what? Active state to partially committed to committed state, committed to terminate state. But in the failure transaction, active state to failed state, or else partial committed to failed state, and from the failed state to aborted state to terminated state. So like the way the transaction states are being executed to completion of the transaction. So here the active state, partially committed state, failed state, and aborted state. So what each and every state, what we can do in the each and every state. And transaction properties. So to avoid that, all the transactional states and the transaction properties are what? Atomicity property, consistency property, isolation property, and durability properties. So with that all the properties, transactions are being executed. With that all properties, transactions are being executed. And the concurrent execution. So in multi-user system, multiple users can access and use the same databases at one time, which is known as concurrent execution. That is nothing but what? So accessing the database, so executing the transactions by the multiple users at different locations by the different operations. That is nothing but concurrent execution. The main problems with the concurrent execution is what? Read or write problems. Read and write operations are the main problems. So that problems leads to what? Data inconsistency problems, and also data redundancy problems. So to avoid this all, we can use applying logs at different levels. That is called as what? Multiple granularity. So applying logs in different levels, applying logs for the different levels of database, like that what? Database and area and files and record. So these are all certain levels of the database. So applying logs at the different levels. To avoid this concurrent execution, we can use the concept called concurrency control. So concurrency control is nothing but what? How to control and manage the execution with the help of different operations. So here we can use the protocols like concurrency control protocols, like log-based protocols, timestamp protocol, and validation protocols. These are all used for the controlling the concurrency process. So concept of serializability. So serializability is nothing but what? To to concurrency controlling mechanism, we can schedule the transactions in serial way and non-serial way. So serial way we can schedule and non-serial way we can schedule. So by scheduling the serial way, we can reduce the concurrent execution also. And last one, deadlock situation. So what is meant by deadlock situation? When multiple transactions are together, are waiting for the resources to utilizing it and executing the same time. So at that moment the collision will occur. So to avoid that collision, to reduce that collision, we need to have some deadlock prevention mechanisms also. So this is all about deadlock in DBMS. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.